When we're solving one-step equations, we are going to be using inverse or opposite operations. So like the opposite of addition would be subtraction, opposite of multiplying would be dividing, and so on. So if I have this equation, for example, some number x plus 3 is equal to 12. Well, I could think, what plus 3 will give me 12 is what I'm asking myself. What number, if I add 3 to it, will I get 12? Maybe we can figure that out without doing official steps, but as we get into harder and harder problems, it really is helpful to know the formal steps to solving equations. So when we're solving, we want to isolate the variable, get the variable all by itself. So I want this x to be on this side all by itself. I want to get rid of that 3. So we can't really just get rid of the 3, we can't make it go away, but I can move that 3 from this side over here to this side. To do that, we use inverse operations. So I'm going to do the opposite. If I do a positive 3, if I do a minus 3, positive 3 and negative 3 makes 0. So we say that cancels, it makes 0. But an equal sign means this is supposed to be balanced. It has to be equal on both sides. So think about like a balance in science. So you're balancing a scale. So to keep this balanced, if I take 3 away from this left side, then I have to also take 3 away from this right side to keep that balanced. So on the left side, this made 0, so they just went away. So that left that x over there all by itself, which is what I wanted. On the right hand side now I have 12 minus 3, which is 9. So then x equals 9. I could always check my answer to make sure that this works. So I can take this 9 and plug it back in here for x. So we can see if I've got 9 plus 3, does that really equal 12? 12 equals 12. And it does, so we know we've got the correct answer. We can also look at an example where we have a subtraction problem. If I have x minus 5 equals 15. So again, I want to isolate that variable. To do that, I want to move this from minus 5, get rid of it. So I'm going to do opposite of plus 5, because this makes 0. Negative 5, positive 5 makes 0. But if I added 5 to the left, it's not balanced unless I also add 5 to the right. And on the right-hand side now, if I add 5 more, I've got 20 altogether. Where on the left-hand side, because these made 0, that just went away, and just the x is left by itself, so x equals 20. And again, I can plug it in. 20, I'm replacing the x with 20, minus 5. Is that really equal to 15? Well, 20 minus 5 is 15, equal to 15. And it is. We know we've got the correct answer. And then we also have other problems where we, instead of adding and subtracting, we can do the opposite of multiplying and dividing. So let's start with the dividing one. If I have x over 2 is equal to 3. X over 2, well, this fraction x over 2, a fraction bar really is just a division sign. So this really says x divided by 2. So then the opposite of dividing something is to multiply. So the opposite of dividing by 2 is to multiply by 2. But just like we did up above, if I do something to the one side, I've got to do it to both sides. So then I've got to also multiply the right by 2. And with fractions, if I have fraction 2 over 2, or for example, if I have 5 over 5, this is just equal to 1. So if I have this 2 over 2, it's really just 1. So it's 1x, but we don't tend to write the 1, so really we just leave it as just plain x. And then on the other hand, I have 3 times 2 is 6. And again, I can plug it in and check. So let's plug this 6 in for x. So 6 over 2, is that equal to 3? 6 divided by 2 is 3. And yep, 3 equals 3, so we've got the correct answer. We'll get one more example of a one-step equation. If I start with something like this, 3x equals 12. When I have 3 right next to an x, or any coefficient with a variable, it really means multiplication. So there's really a multiplication sign in here. We just don't tend to write it. Just like if I have 1x, we tend to just write x. And just like if I have something plus 0, we just tend to write the something. We don't need the plus 0 because that won't change it. So this means times. And the opposite of timesing by 3 then is to divide by 3. But again, keep it balanced. Divide both sides by 3. 3 over 3 is 1. So 1x or just x. And then 12 divided by 3 is 4. And again, I can check my work. I can plug in, I said x is 4, so I can plug that in for x. 3 times 4 equals 12. 3 times 4 is 12, so yes, 12 equals 12, so we know we've got the correct solution. So we're always using inverse operations, using opposite operations in order to solve equations. We can always plug it back in to check it.